the pivot point of the dummy is exactly on the surface where the camera hits the sphere, and if we would switch the viewport to show the camera view, then the dummy would be exactly in the center of the viewport. This means that we can use now the viewport as a targeting device and create a new intersection from the view, and let's say another point helper exactly at the center of the viewport where we hit. Now let's see how the intersect ray function could be used to achieve a simple real-time collision detection effect. Let's first create a couple of objects. A box with a height of 100 units and cross section of 10 by 10. Let's then create 9 copies and multiply again to create an array of 100 boxes. And let's create a sphere which we're going to use as the collision detection object. Now let's write a script which is going to assign a new scripted controller to the height of every single box. For O in all the boxes, do the following. The height controller is going to be a float script. The content of the script will be first accumulated in a variable called text, txt. First we want the scripted controller to depend on the sphere 01 position controller. Then we are going to add to the same variable the rest of the code. We'll create an intersection using intersect ray between the sphere 01 and a ray value starting at the position of the current object and pointing straight up along the positive z-axis 001. Then if the intersection was not undefined, then we will calculate the distance between the intersection point and the position of the object. For that we're going to take the length of the intersection position minus the position of the object and if this value is greater than 100, then we'll take 100. Otherwise, we'll use the calculated distance. In case that the intersection was undefined, this else corresponds to the first if. In that case, we're going to simply return 100 in order to keep the original height of the box. Finally, we'll assign to the script property of the scripted controller